Hello, this is Jun Koo. This is a PowerPoint presentation for the impact of human factors in aviation accident. A research project for the Aeronautical Science capstone course for the Bachelor of Science in Aeronautics degree. The overview of this presentation includes following: the brief description of the research article, defining human factor, the peer model, defining human error, the dirty dozen, case studies, and conclusion. Human factors contribute majority of aircraft accidents, especially in the field of aircraft maintenance. Nearly 70% of aircraft accidents are caused by human factors that manifest in aircraft maintenance. This capstone project is determined to unravel all the human factors behind aircraft accidents. It sets up by defining the human factors and human errors to create a firm foundation for the project. The peer model is then elaborated to provide a background against which human errors could be measured. To understand the human factors better, the project explores the dirty dozen and its mitigating measures. Lastly, notable aircraft accidents are discussed under the case study as real examples of how maintenance occurs, most of which spring from human factors are to blame for the most aircraft accidents. When it was discovered that most aviation accidents are due to human errors rather than mechanical hitches, the term human factors drastically gained popularity in commercial aviation industry. The term human factors is cross-disciplinary and has its roots in fields such as industrial design, psychology, statistics, engineering, anthropometry, and operations research. The term involves the scientific understanding of human capability and its application to the design, development, and use of systems. It also encompasses the effective use of human factors in maintaining a work environment. There exists a wide range of human factors associated with aviation maintenance and performance of various tasks. The human factors involve numerous challenges unique to every person to worker since people have different strengths, capabilities, and weakness. The study of human factors involves many concepts. However, aviation maintenance should have a uniform view of human factors to avoid confusion. The peer model has been in use for more than a decade to denote human factors associated with aviation maintenance. In full, the acronym PEER means the P, people executing a task; E, environment in which the task is executed; A, actions involved in the execution; R, resources used in execution. Human factors programs in aviation maintenance concentrate on the people tasked with the given work. The programs incorporate factors psychological, psychosocial, and physiological in nature. Such programs should be centered on the person, his physical capabilities, and various factors affecting him in performance of the work in question. In addition, the program should take into account the cognitive capacity, state of mind, and conditions that are likely to affect the person as he interacts with other members of the team. Because people have different strengths, experiences, standards, and sizes, it is advisable to apply matching characteristics to specific tasks performed by the person. An effective human factors programs take into account the limitations, characteristics of humans, and shapes the job properly. Rest breaks play a significant role in the shaping of a job to incorporate human factors. It is common for people to suffer mental and physical fatigue when working. When a person is allowed adequate time to rest, the strain associated with the task do not overpower his capabilities. In addition, there's a need for sufficient lighting in a workplace, especially where elderly workers are involved. By testing the sight and hearing of workers on a regular basis, optimal human physical performance can be guaranteed. Physical disabilities are not eradicated by paying greater attention to an individual. Instead, a good program should look into psychological and physiological factors affecting a person's performance as well. The physical and mental health of workers should be maintained properly. One way to do this is to avail educational programs that touch on health and fitness. Healthy mentals, drinks, healthy meals, drinks, and snacks could substitute sick leaves. Programs aimed at reducing drug reliance should be incorporated as well. Teamwork and communication are yet other issues that affect people performance. There should be ways to enhance cooperation and communication among workers and senior staff. Systems should be in place to reward workers for their efforts in, in improving operations and ensuring maximum safety. Two environments have been identified in aviation maintenance. There are the physical and organizational environments. A program on human factors should pay greater attention to both environments equally. The physical environment encompasses humidity, temperature, lighting, cleanliness, noise control, and the design of the workplace. These conditions are essential to worker performance and should be acknowledged through cooperation with workers for purposes of accommodating or altering the environment to suit workers. Addressing the physical environment is not as easy as it sounds. Much commitment on the part of the management is needed to put things together right. The organizational environment is more abstract in nature. Significant factors involved in this environment revolve around cooperation, shared values, mutual respect, communication, and the organization's culture. Leadership, communication, shared goals of profitability, safety, and other factors play a huge role in promoting an effective organizational environment. Great organizations support and guide their workers alongside promoting a culture of safety. With safe culture is meant a culture that shares values and attitudes towards safety. In such a culture, all persons acknowledge their roles towards achieving the organization's mission's safety. Effective programs of human factors look into actions to be performed by workers for job efficiency and safety. Also known as Job Task Analysis, JTA, this approach helps identify the skills, knowledge, and attitudes required to execute each task successfully. JTA helps identify the tools, instructions, and resources required for successful execution of a task. When JTA is followed properly, each worker will receive sufficient training and each workplace will be well equipped to facilitate the execution of the task in question. Most regulatory authorities recommend the JTA as a foundation to an organization's training plan. Human factors challenges relating to technical documentation and job cards fall within this category of the peer model. Distinguishing resources from the foregoing peer elements is hard at times. The characteristics of environment, people, and actions inform the kind of resources needed to execute a task. Most resources are tangible in nature and include tools, lifts, computers, test equipment, and technical manuals. Certain resources, however, are less tangible. These include staff qualifications, time allocated for a task, and communication among workers. The resources element needs a broad definition. Put simply, a resource is anything necessary for a technician to execute a task effectively. Protective clothing is a good example of a resource. A mobile phone could also be a resource. The same applies to the rivets. As a pure element, resource is significant for helping a certain additional resources needed to execute a given task. Human errors, by definition. Human error is any action of a human being that has unintended consequences. On its own, error is not a big deal. However, when the same mixes with aviation maintenance to produce negative consequences, there is a serious cause for alarm. Avoidance of errors through risk assessments and training should not be given much weight. These measures should enable the identification of errors early enough before they lead to damaging consequences. In simple terms, managing human errors is better than avoiding the same. Human errors are of two types, unintentional and intentional. On the other hand, there are two kinds of human errors, active and latent. Unintentional error occur when a person deviates or wanders from accuracy. Possible inclusions could be errors in action, opinion or judgment that happen due to carelessness, insufficient knowledge, or poor reasoning. Intentional errors in aviation maintenance are violations per se. Someone who chooses to do a wrong thing knowingly or intentionally commits a violation. This means that the person has wandered from safe practices, procedures, regulations, standards, or norms. An active error refers to a particular activity by an individual that is obvious. A latent error, on the other hand, refers to the underlying issues of the organization that cause the erroneous activity in question. For instance, an AMT uses a letter that he knows is broken. The active error in this scenario is the fault from the letter, whereas the latent error is the broken letter that should have been repaired by the organization. The dirty dozen is a phrase used in aviation to refer to the most common human errors that cause accidents. It is developed by Gordon DuPont in 1993. These 12 elements play a major role in influencing mistakes by individual. The concept has been acknowledged internationally as an integral part of the training programs and courses on aviation. Originally developed for aircraft maintenance, the Dirty Dozen is now incorporated in many documents. The following is 12 elements of the Dirty Dozen. Lack of teamwork. Personality difference in the workplace must be left at the door. Organizations should emphasize that a lack of teamwork can ultimately affect the safety of maintenance work. In order to avoid lack of teamwork, it is important to ensure that lines of communications are always open between personnel. Also, discuss specific duties when jobs require more than one person to eliminate any questions. Always look out for coworkers with safety in mind. A distraction could be anything that takes your mind off the task that is being done. Any distraction while working can cause us to think we are further ahead in the process than we actually are. To avoid distraction, always use a detailed checklist. Never leave tools or parts laying around. Secure them before leaving the area. Once returned to the job, Go back through all the steps to ensure where you left off. Occupations that require an individual to work long hours or stay up overnight can lead to a fatigue. Fatigue can cause a decrease of attention and a decreased level of consciousness, which can be very dangerous when conducting maintenance. To minimize fatigue, it is important to be aware of the symptoms and look for them in yourself and coworkers. And talk to someone that you feel that you're exhausted and tired. Also, eating healthy, exercising, and regular sleep patterns can prevent fatigue. Lack of communication. Maintainers must communicate with one another and explain what work has and has not been completed when changing shifts. To mitigate the risk, ensure that maintenance personnel are always discussing exactly what has been and needs to be completed to the next shift. Never assume that the work has been completed. Also, properly use logbooks and worksheets to communicate work accomplishments. Lack of knowledge. In a world of ever-changing technology, maintainers must remain up to the date on current equipment and how to fix it. If you don't know how to fix something, ask for help from someone who does. And ensure that the maintenance manual you are using is up to date. Only fix parts that you are trained to fix. Complacency. People tend to become overconfident after becoming proficient in a certain task, which can mask the awareness of dangers. To mitigate the risk, it is important to always double check your work and always expect to find something wrong. Also, never sign off something that you did not fully check. Pressure. Work in a dynamic environment often involves pressure, where the pressure of meeting a deadline hampers with the ability to execute tasks effectively. The pressure is regarded as too much. In order to mitigate the risk of pressure, ask for extra help if the time is an issue. Communicate if you think you will need more time to complete a task rather than rush through it. Ensure that the pressure is not self-induced. Lack of resources. Where spare parts are unavailable to execute a maintenance task, the technician would be pressured to execute the task using inappropriate or old parts. The absence of one or more of the resources could interfere with a person's ability to execute a task effectively. To mitigate the risk, preserve all equipment through proper maintenance. Never replace a part with one that is not compatible for the sake of getting the job done. Maintain a sufficient supply of parts and order any anticipated parts before they are required. Lack of assertiveness in failing to alert others when something does not seem right can result in many fatal accidents. Do not let something that you know is wrong continue by ignoring that it is there. After completing the same task multiple times, maintainers can develop a lack of awareness for what is around them. Common sense and vigilance tend to not be present because they have completed the same work so many times. To mitigate the risk, always ask coworkers to check your work. Even if you are highly proficient in a task, always have someone check your work. Check to see if what you are working on conflicts with an existing modification or repair. Stress is the subconscious response to the demand placed on a person. When such a situation happens at work, there's a risk of overreaction in an inappropriate way happening often and easily. To mitigate the risk, take time off or a short break if you're feeling stressed. Healthy eating, exercise, and sufficient amount of rest can reduce stress levels. Discuss with the coworker and ask them to monitor your work. Also, it is necessary for organizations to have a means of assisting employees, including stress reduction programs. Norms. Norms is short for normal or the way things are normally done. They are unwritten rules that are followed or tolerated by most of the organizations. Negative norms can detract from the established safety standard, can cause an accident to occur. To mitigate the risk, it is important to ensure that everyone follows the same standard. Be aware that just because it seems normal does not make it correct. The easiest way of accomplishing something may not be the standard. As mentioned in the foregoing discussion, most aircraft accidents are caused by human factors. Most of these human factors manifest in aircraft maintenance. In the period spanning 1994 to 2004, maintenance errors caused 42% of aircraft accidents. Maintenance error results from breakdowns in the organization processes, culture, and decisions. In addition, the errors are caused by human factors that are majorly due to organization weaknesses. Notable accidents in history include the following. Japan Airlines Flight 123. The airplane suffered mechanical failures just 12 minutes after it took off, crashing half an hour later. Based on a photograph captured during the flight, the airplane's vertical stabilizer was missing. Records show that the airplane had been involved in a minor tail strike accident 6 years before damaged its rear pressure bulkhead. Repairs carried out on the damaged part did not conform to approved repair methods. As per the procedures, a single continuous double plate of 3 rivet rows was to be used in reinforcing the damaged bulkhead. On the contrary, the technicians used 2 double plates with 1 and 2 rivet rows respectively. The error diminished the fatigue resistance of the part in question by a massive 70%. Upon the bulkhead giving away, the explosive decomposition that resulted therefrom ruptured all the hydraulic system. The plane became uncontrollable. Alaska Airlines Flight 261. The plane plunged into Pacific Ocean as it flew from Puerto to Seattle. The cause of the accident was established to be the loss of pitch control resulting from thread failure at the jack screw assembly that controlled the horizontal stabilizer trim. This failure was due to insufficient lubrication at the jack screw assembly conducted by Alaska Airlines and its preventive maintenance schedule. The failure happened despite the record showing the lubrication job had been done. Chuck's Ocean Airways Flight 101. The aircraft lost its right wing a few minutes after it took off and plunged into a beach. Investigations reveal a metal fatigue failure on the plane's right wing triggered by a crack. The maintenance team had earlier detected the crack and repaired it, but the repair was done ineffectively. Investigations by the safety board produced a report that revealed numerous maintenance problems on the company's planes. This raised questions on the company's maintenance practices. The safety board also established undocumented maintenance and improper repairs. The remaining fleet following the accident suffered from extreme corrosion and showed signs of poor repair during maintenance. Aero Peru Flight 603. As soon as the aircraft took off, it dawned on the crew that the basic flight instruments gave contradictory and erratic readings. With basic flight instruments lacking, contradictory warnings from the flight computer, and the belief that the plane was at the safe altitude, the plane turned back to the airport after the pilot declared an emergency. Unfortunately, the plane lost track of altitude and location, crashing into the ocean and killing all passengers. Investigation into the instrument failure revealed that the maintenance worker failed to remove a duct tape temporarily placed to cover static ports during a routine wash, meant to provide a cockpit with the correct data. These ports are critical to all operations of flight instruments, providing basic data, including altitude, airspeed, and vertical speed. The data is useful to the pilots as they inform warning when the flight nears dangerous levels. Conclusion. Human factors come in different dimensions and apply differently from one person to another. This project was endeavored to explore the significance of human factors in aviation accidents. The pure model gave a comprehensive presentation of what is expected of a company and its employees. The model is applicable to airline operators and owners as well. The same principles were reiterated in the Dirty Dozen, whereby 12 human factors were explained, with comprehensive mitigating measures accompanying each other. To avoid aviation accidents now and in the future, it is necessary to learn from previous mistakes that have led to loss of lives and money, as discussed in the case studies section. Airline companies should apply the Dirty Dozen mitigation elements effectively if there's to be a change. The number of accidents has declined significantly in the last decade. This shows that the airline companies are towing the line gradually. However, there still much need to be done as new human factors manifest in many different ways every day, a situation that could cause serious trouble in the future. Further research is necessary to find solution to all possible risk. Thank you.